Hello and welcome, everyone. Thank you for joining us for another session of our Day One Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. In today's session, you'll learn how to configure and manage PostgreSQL through the OCI Console and gain insights into key operational best practices to ensure a successful and resilient rollout. And now, I'd like to introduce you to our esteemed speakers, Dev Vaidya and Mike Sorolla. And with that, I'll turn it over to Dev.
Thank you, Borna. Hello, everyone. Thank you so much for joining today's session, Day One and Beyond Hybrid Search with OCI Postgres. Super excited to walk you through Postgres as a database and then specifically what it is here at OCI. So without further ado, we'll jump right in. Today's agenda is going to be an overview of Postgres. We'll talk about the open source database Postgres and why do customers choose it. We will also jump into what is the OCI differentiation when it comes to Postgres. From there, I'll hand it over to my colleague Mike, who will run us through a console demo of OCI Database with Postgres, as well as a demo of our hybrid search with Postgres. So this actual Postgres implemented and running in a AI retrieval augmented generation type workflow. So that's what we're going to cover today. First, wanted to just talk about Postgres as a database, right? So what is Postgres? It's a powerful open source relational database. It's known for reliability. It's known for robustness, advanced features. It's had 30 years of active development. So it's been around for some time. Strong open source community. And there's a host of reasons why customers choose it, right? You have a lot of options when it comes to databases and that too open source databases, but Postgres supports SQL standards. It is incredibly extensible. For example, if you have geospatial data, there's an extension PostGIS, which will be specifically to help you with those types of data workloads. PG Vector, if you're having AI or semantic search type workloads, that's an extension of Postgres that will support you for that. PG stat statements is an example of one where you can immediately see which queries are running slowly and get a little bit more insights and metrics into your database. So just there's extensions for everything when it comes to Postgres. It's very extensible. It's high performance and highly scalable, right? You can handle complex queries, really large data sets, well into the terabytes. It's fast. It's parallel processing, indexing, partitioning. So all the requirements you would expect of a enterprise-ready database comes with Postgres. Advanced features, JSON-B, full text search. It's fully ACID compliant, multi-version concurrency control. So this is where if you have two transactions or two attempts to change the same row, there's going to be control around that. So you're not writing over. There's going to be locking to make sure that things happen sequentially or in the right way. Window functions to do things like ranking. So it's just really advanced features that you can use for handling any type of workload. A strong ecosystem, right? So if you want your management and observability, you have PG admin, which you can connect right in and kind of administrate your Postgres database. Really a good system of ecosystem. A good ecosystem around this database in general. And then what we've seen is that, if you're just getting started, your startup, this is a great way to get started with Postgres. It's very easy to get up and running, easy to use, and all the way up from, if you're a full enterprise that just needs a highly reliable, highly performant database, Postgres is an answer there as well. We've seen it adopted across the stack, across different sizes of companies, and just a good solution overall for a database workload. So it's one of the more popular databases as well. Another huge reason why customers adopt it, right? We talked about how there's a robust open source community, 30 years of development. And that's really propelled it to a top 5 popularity database on DB engines. And in fact, on Stack Overflow, it was rated the most popular database. So preferred by 52% of professional developers, most popular for the last couple of years from this 2024 poll. So continues to just gain in popularity, continues to be a favorite, again, because it's super extensible. It keeps up with the times when it comes to, AI extensions like PG Vector. So just a good database to have by your side. So at OCI, Postgres is just going to be a piece of your entire stack, right? We have, of course, Postgres, but along with that, we have OpenSearch, we have Redis Valkey for caching. So we have other open source databases supported as well. And there's a whole host of data management services ready for you, including Oracle database. So this is part of the stack that OCI offers that, we have a complete cloud service offering that will complement your database. We are also committed at OCI to support open source in general. We're seeing a lot of enterprise really embrace and adopt open source pretty regularly now, Postgres being a part of that, but all of the brands that you see here, right? Like we'll see a lot of Kubernetes where it comes to containerized and more easily managed infrastructure deployed via containers, Docker, et cetera. So we're committed to that as well. This really helps portability and helps customers avoid vendor lock-in, which we know is top of mind. If you're deploying on an open source database, you don't have to worry about vendor lock-in because this will be supported by all major cloud providers just by the fact that it's open source and it's very well supported by the community. So in terms of our open source timeline, you'll see that Postgres actually was launched late 2023. So about a year and a half in at this point. We're running very quickly. We've implemented a lot of great functionality. We're used by a lot of enterprises and trusted for that reason. But as you can see here, there's a whole journey that we've had in terms of open source services that our customers have demanded, and we've continued to provide. Okay, so let's say you have decided on Postgres as your option that you want to go with your database. You appreciate its extensibility. You appreciate how it has really good advanced tooling, and you're saying, okay, this is the one I want to go with. There's a few ways you can go about deploying your Postgres, right? You can self-manage it, which means that you're going to run it directly on your VMs or maybe via a Kubernetes deployment. And that's something that you have to manage, and we'll talk about that. Or you can go with a managed approach where a lot of the operations are managed for you and you don't have to worry about that. So let's take a look at if you were to self-manage today, right? That means you're running on a VM, you're running in Kubernetes. The challenges are that there's a lot of operational overhead, right? When you are running it on your own, you have to patch it, you have to upgrade it, and new versions come out. There's maintenance, resource management. There's a lot of developer time that goes into just making sure Postgres is functioning securely and with the latest and greatest that it has to offer. And as a result of all of that extra developer time focused in, there's a high total cost of ownership associated. So you have to, of course, pay for the infrastructure, but then pay for just managing the database overall. Data loss, so any kind of disaster recovery, that's up to you in a self-managed scenario. So this is anything around, replicas that you have to set up, making sure that your data is secure within region, across regions, that kind of high availability. It's up to you to set up in a self-managed scenario. And then finally, scaling, right? As your application grows in traffic, or maybe even you have busy periods and lull periods, kind of the scaling aspects on a self-managed would be up to you. You'd have to increase the size of your nodes, add more nodes. All of that is managed by your team. And that can get expensive very quickly, especially for high traffic enterprise applications. So that's where a managed service comes in, right? So the fully managed Postgres service on OCI, we automate all of the operational overhead for you. So that's high availability. We have high availability built in as part of our offering. We manage patching for you, upgrades, automatic backups, scaling, compliance. So you, as your development team, get to do what you enjoy, which is building out the features that you care about for your customer, right? You don't have to self-manage any of the operational overhead of Postgres. That's done for you. So operational expense can drop up to 75%. The way it's built at OCI can run 3 times faster than self-managed, so there's also a performance benefit. We back up our offering with a 4 nines availability SLA, so you can be confident that your application will stay up. And then on apples to apples configurations, we also cost less, up to 60% than other hyperscalers. So we'll talk about all of these a little bit more in detail. But overall, a managed solution is just going to save you time and money so you can focus on building the features your customers care about. So we tend to see that when it comes to kind of the cost of managing a database like Postgres, and this is not just Postgres, right? I'm trying to zoom out a little bit to give more context, but any kind of self-managed versus managed database offering, your managed is going to give you the availability, the multi-region, everything we talked about here that gets the operational side that gets managed for you. That tends to be about 3/4 of your overall management cost at scale, right? If you're an enterprise level scale. If you're just starting out, you're a startup or you're just kind of kicking tires, maybe this is too much. Maybe you don't need this level of scale, but definitely at the enterprise level for preserving the data of your customers, it's an absolute must to have robust availability and management of operations. So the service cost, which is the fee to actually run and use the managed service, is about 1/4 of the overall, but you're saving on the operational cost, which tends to be the bigger piece of the iceberg. So the way that our Postgres specifically differentiates, right? So what you'll see otherwise outside of our services, whenever you spin up a node, let's say you have your primary and you want to spin up a couple read replicas off of that primary. Other services, other providers, you'll have storage that is spun up as a part of the read replica. So each replica will have its own volume associated to it. And what we have done at OCI is what we call OCI Database Optimized Storage, where we have a single regional block volume behind your nodes in your cluster. And that's what we call the database optimized storage layer. So rather than one volume per node, you have a single pool of storage behind that spans across availability and fault domains. So it's highly available. And therefore, every time you're spinning up read replicas or spinning down read replicas, you're only having to manage the compute. You're only spinning up the compute. You don't also have to spin up the storage that's already existing behind the scenes. So that means spinning up replicas is much more quick because you're only having to, again, spin up the compute. It simplifies your high availability. There's no configuration required. There's a performance benefit than a replication base where you're kind of having to manage that replication across nodes. We have a zero recovery point objective. So RPO is an industry term on how much data would you lose in the event of a disaster. So thanks to our database optimized storage layer, we are able to offer a zero RPO, a zero recovery point objective, meaning no data loss. And then there's fast failover as well, because that data is local to all nodes. So when you're failing over, the data is already there. It doesn't have to be recreated as a part of that failover. So a lot of benefits in the kind of the science that went into the thinking here for how we built our OCI Postgres. And one of the coolest features, I think, is that there's dynamic storage scaling. So on other providers, you would likely have to, on a provisioned offering, you'd have to guess how much storage you're going to need. And then you'd pay for that storage. It's called provisioned storage. So maybe you're like, hey, I need 10 terabytes. You might only end up using 6, but you have to pay for 10 and provision 10. And on our offering, that's not the case. So the storage will scale dynamically. You only have to pay for the storage you use, not even provision. So in my example earlier, where you're thinking that you're going to use 10 terabytes, you only end up using 6. You're only going to pay for the 6 in our service. And if your storage footprint reduces to say 3 terabytes, then it'll automatically size down and you only pay for the 3 terabytes. So that'll scale with you and for you as your traffic scales. So you don't have to worry about that, right? So just one less thing for you to have to manage. And then on the performance side, we offer up to 750,000 IOPS from we start at 75,000 all the way up to 750,000. So really a lot of performance to support any type of workload and demands at scale. So we talked about the high total cost of ownership. This is a slide to show that at a configuration of 32 cores, 512 gigabytes of RAM. So just as, again, a zoom out, whenever you deploy a managed database, again, this is going to be not just Postgres, it's going to be across the board. You're going to have some amount of compute that you're going to need to handle your traffic. And that's going to be in the terms of CPU cores as well as memory. So that combination is your what's called your compute. So in this cluster configuration is 32 cores and 512 gigabytes of RAM compute. And then you'll need to know how many replicas you want in your cluster, right? So your cluster is going to be your primary node plus all the replicas. So in this case, you're going to have 3 replicas of the size 32, 512. And then your final component here is going to be your storage, how much storage you're going to need as a part of your deployment. And in this configuration, it's 850 gigabytes. So again, you have your compute, you have your replicas, and then you have your storage. And that all together is the kind of building blocks for what your deployment is going to look like, what your database deployment is going to look like. And so when you take this configuration, which is a typical configuration of an enterprise scaled workload, a large workload at that, we do come in 60% apples to apples when you're looking across other providers. We also have inter-region data transfer free. Competitors can bill for that. So generally speaking, we are at a cost advantage to other providers. So this is the way we bill for our service. Different providers will have different ways they go about billing. So this is how we do it, where you're going to have your managed Postgres service fee, which is going to be billed based on how many CPUs, how much compute you're using. And then per gigabyte per month, there's a charge associated to your storage. So if you're using a terabyte, that's about 1,000, gigabytes, 1024, how you look at it. You multiply that by the price, and that'll give you how much you're going to be paying for that storage per month. And again, this will scale up or down dynamically. So that's what you pay for the managed component. And then there's the infrastructure fee. So this is what you would pay if you were directly deploying and managing that Postgres by yourself. So this would be the compute cost for the OCPUs, compute cost for the memory. That's going to be the OCI compute charge that you'd see on our website for using the compute directly. And then based on how much performance you need for your storage, there's a pricing associated to that. We have it as VPUs, virtual performance units, which is a proxy for IOPS, which is a industry standard metric for like input outputs operations per second, which is how block storage performance is measured. Storage performance for a database is measured. So again, you have your managed service fee, and then you have your underlying infrastructure fee, and these two together combine to form your bill for a managed Postgres on OCI. So we talked about disaster recovery being top of mind for a lot of our enterprise scaled customers, right? It's absolutely important to ensure that customers' data is maintained in the event of a data or a disaster event. So our clusters are highly available by design. We touched on this briefly. Thanks to the unique database optimized storage, it duplicates data on multiple physical locations. So again, you have a regional block volume, and then that spans across multiple availability or fault domains, and the data is kind of replicated across. So your high availability in a region is handled for you, and it is robust as a result of this design here. Scaling. Okay, so this is another important topic, especially as your application grows in traffic, right? So just as a more general concept of scaling, before we talk about OCI, scaling can happen in 2 primary ways, right? You can either scale up, which means we had talked about the OCPUs and the memory. Scaling up means adding more CPUs or more memory, basically more compute to your existing node or nodes to handle an increase in traffic, right? So maybe I'm at 8 OCPUs and 64 gigabytes. I scale up to 16 OCPUs and 128 gigabytes. And that's scaling up. The other way to do it is scaling out, which is you add replicas to your cluster. And for example, in the same setup where you have a 8 CPU, 64 gigabyte setup, you can add other replicas off that size. So rather than going up in CPU and RAM, you just add replicas at the same size. So you have more nodes to serve traffic in your cluster. And why would you want to do one or the other? Well, when you scale up, I guess one thing to keep in mind is writes are always going to come to your primary, and then they're going to replicate out to the replicas. And in our case, it's going to be via that database optimized storage layer. So if you have a lot of writes, like write-heavy traffic workload, you'd want to scale up your primary because your replicas can only serve reads out to your customer. They cannot take in writes. But if you're seeing a lot of read traffic, then it makes sense to add more replicas and scale out because those will serve the reads while the primary continues to handle the writes. So it'll be depending on your workload and your traffic patterns. But coming back into how OCI handles this, you'll have your primary, which again handles the writes and serves the writes for your deployment. And you can add up to 7 replicas in your cluster. So really can scale out to serve those reads as needed. So looking at the features that we have available today as a part of our OCI managed offering, it's fully managed, as we talked about. We talked about dynamic storage scaling, vertical scaling in place. This is scaling up or down, as I mentioned, adding OCPUs or RAM as needed, or adding storage performance as needed. We have flex shapes, and what this means is you have the ability to add small increments of OCPU or RAM. You don't have to scale up 2x or 4x every time you want to scale up. You have very incremental scaling that you can achieve as a result of these flex shapes on our service. Backups, we have the ability for you to set up automatic backups that can be taken daily or weekly. And you also have the ability to take on-demand backups, manual backups. Automatic backups are retained for 35 days. Manual backups can be retained indefinitely. And then these will be billed at object storage billing rates. So we do have that functionality for just making sure your data exists and you have a copy of it. Managed patching, scheduled maintenance. So we have a maintenance window wherein we handle any kind of patching or security updates for you. Monitoring metrics, we have a metrics and monitoring dashboard within the console where you can see top metrics like CPU load, RAM load, etc. And from that dashboard, it's just a few clicks to set up notifications and alarms on any kind of the metrics that you care about. We have full Terraform support. We automate minor version upgrades again during that maintenance window, so you don't have to worry about that like you would have had to in a self-managed approach. Multi-availability, domain data replication. That's a long one to say, but this goes back to being able to replicate data across fault domains thanks to that regional block volume. So it's contributing to your high availability and disaster recovery. And as a result, very low RTO on a multi-node, which means a primary plus at least one replica is a multi-node. Your recovery time objective is going to be less than 2 minutes. On a single node, it's going to be less than 20 minutes. And recovery time objective is if there's an event where your database goes down, this is how long it'll take for it to become operational again. So our RPO is 0, so you won't have any data loss, but the downtime if during a disaster is very low at less than 2 minutes for a multi-node just to get back up and running. We have cross-region backup copy. So this is a highly requested feature by our enterprise customers. They wanted to not just have that disaster recovery within a region, but they wanted to have it across regions in case of a regional failure for whatever reason, which is rare, but they wanted to have that resiliency often for compliance purposes as well. And to that end, we delivered the cross-region backup copy feature. So you can take those backups that I mentioned earlier and actually ship them across to a different region. And then you can restore from that backup in that region and therefore have a sitting copy of your database in another region for DR purposes. And then in the same region, we have automatic or manual failover handled for you. Excuse me. And then on the security side, we have end-to-end encryption and automated security patching. We support versions 13 through 16, Postgres versions 13, 14, 15, 16, stored procedure languages. We have a whole host of extensions that we support, like a few of them that I alluded to earlier, but you can see the full list here on our documentation. And then in terms of service limits, we go all the way up to 32 terabytes of storage for your Postgres database, 1,024 cores, 16 terabytes of RAM, which is far more than what most customers need. So we're able to scale quite up based on your requirements. And then in terms of what we've released recently, right? So as I mentioned, we launched late 2023. We are sprinting on how quickly we're able to achieve releases here. So really excited and proud of the team on that front. But what we've had recently was, version 15, version 16 coming out. We're trying to stay up to date with those. The current version out is 17, and that's on our roadmap here. Several extensions. When a customer needs an extension, we will work to make that available. We recently did PG Logical, which allows logical replication between two databases across versions. So that's very good, again, for real-time kind of synchronization and also for disaster recovery. We talked about the cross-region backup. We have a dedicated read replica endpoint. So as I mentioned earlier, your read replicas also serve reads in addition to your primary, but customers wanted a single endpoint to kind of point their applications to, and then that would manage and load balance reads all across the cluster. So we do have a dedicated read replica endpoint. So just to kind of look at it, your writes would go into your primary via that endpoint, and then reads would come in via the read replica endpoint and would be kind of managed for you in terms of load balancing. And we have integrations as well with OCI Golden Gate, and I'll talk about that in a second here in the context of migration. So OCI Database with Postgres, it's extensible and it's open source for a variety of use cases. So this is a kind of view into how our customers use it. You can log in directly to the Postgres database, SSH. That's for users, or your application can come in via an API. And then we've seen it deployed, your application via containers, virtual machines, really, a variety of ways that you could have your application layer. And as that processes incoming requests from the API or from users, it serves it to the backend, which is where your database would live. And again, Postgres here, very great solution for online transaction processing, spatial data, online analytics processing, and then vector database via the PG vector extension. So that's going to enable your artificial intelligence workloads and semantic search, things like, we'll get into that in a second with the demo. So again, our service is fully managed. So you're spending less time managing, more time developing features customers care about. It has that instantaneous failover thanks to the database optimized storage, and it's fully compatible with PostgreSQL. We're 100% compatible there. So there's no vendor lock-in. You can migrate and start using the service right away if you're already using Postgres. As in terms of a reference architecture, we see often on the left side, you'll see customers often interfacing with Postgres and OCI via on-premises or via their application in the internet. That comes into the OCI region via either a Fast Connect if it's on-premise, or a WAF if it's via the internet. And within the OCI region, you're going to have your virtual cloud network. And within your virtual cloud network, you're going to have various subnets. And each subnet kind of is like a, if you will, like a section of your virtual cloud network dedicated to a specific use case. So you'll have a subnet for your database with Postgres in the bottom right here, a subnet for your cache, either Redis or Valkey. And we do see customers using your Postgres and your cache together often, especially for high traffic, high read type workloads, because Redis, Valkey is great for serving those reads for data that's kind of persistent and not dynamic, not changing too much. And then the data that is changed often goes back into Postgres. So these two work very well together, Postgres and cache. So in this case, they'll live each in their own subnet. You'll have your front-end application subnet that can auto-scale if need be based on the traffic coming in. That communicates with your back-end database. And then you'll also often see a bastion subnet, which is where if you suppose need to SSH directly into the Postgres database or into the cache, you can use that bastion server to do so without exposing your backend directly out to the internet. And then all of this has a service gateway that you can use to interface with other OCI services or really other cloud services, right? This is going to be applicable to any cloud here. Talking about in the context of OCI, but I want to make sure that there's value across the board. So yeah, and there's going to be a service gateway that's going to be able to talk to object storage, identity and access management, cloud guard, any kind of security, customer managed keys in a key vault, any kind of monitoring solution. So this is the way that we see customers deploying their applications, especially in the context of Postgres and a cache. I'm not going to go word for word on these slides. I'm going to speed up a little bit here, but we do have several large-scale enterprises already taking advantage of our OCI Postgres service and really having a great time with it, right? They're seeing a lot of cost savings, faster implementation, right? They just get up and running much more quickly with our service thanks to the way it's been architected. Better performance. They're coming in with Kubernetes. They're having a lot more utilization on their core. So it's just better price to performance, better efficiency. So overall, it's just been really great to see customers on board with hundreds, many databases of all shapes and sizes, and just kind of succeeding with us. We have a team ready to help as well when it comes to migrations, and that's what I wanted to touch on quickly here. So there's a couple ways to migrate. One is your native PG dump, PG restore, which exists within Postgres as part of it as an open source tool. You dump your database and then you restore it into your target cloud destination or wherever you want it to be. We have, of course, support for that functionality, the native PG dump, PG restore. We also support OCI Golden Gate, where it's going to be real time, right? PG dump, PG restore, there's going to be some level of downtime between when you dump and you restore. If you cannot have that, which at enterprise levels, most of our customers cannot, we have a solution via OCI Golden Gate where you connect your source database, which we have a whole host of databases we support on the source side, connect it to OCI database with Postgres via Golden Gate, and then that'll real-time stream over for migration purposes, for synchronization purposes, and it's a really great solution for just getting data over. So if that's something you're interested in, you want to understand or learn more about our service, OCI Database with Postgres, we encourage you to schedule a 30-minute demo. We will talk about our service and then really just understand what your needs are as a customer and just kind of be there for you, make sure that we're able to help you out with whatever you need, and ultimately work towards what would a good POC look like to help you achieve those goals and objectives. Now, with that, I'm going to go ahead and turn it over to my colleague, Mike, who's going to do a demo of our Postgres console. Thank you so much. Go ahead, Mike.
All right. So as Dev mentioned, he took you through the overview of our managed Postgres service. It's been around for a little bit now, a little over a year or so, and it's taken off tremendously with the usability. Our team's been adding to it. So with that, I'm going to give you a firsthand look at some of the simple ways that you can manage a Postgres database, and I'll take you through the steps here of how we create a DB system, how we're going to change the performance with IOPS, if you need to add a replica node for high availability, also our backup policy, and if you need to change that. And one of the things that Dev mentioned too is cross-region backup copy, where you can store a copy in a different region. So we'll start here with our OCI console. So when we're in the console, if you go over here to this navigation menu, you scroll down to databases. You click databases, and then we have all of our databases here. So here's Postgres. When we go into Postgres, you make sure you select compartment. You have your region that you're looking to deploy in. There's a database that I've already created, but for sake of time, I'll go ahead and show you how we create a database. So there's two ways that you can create one. You can create one from scratch, a brand new database with this option here, or you can create a database from a backup, and you can select which backup you want to pick there. As you can see that this one does daily backups and has a retention of, I believe, 3 days here. So going back to creating a database from scratch, we'll go ahead and select this option, create new database system. Once we're in here, this is where we add all of our details. So we go through and we'll give the database a name. You can change the name there. You can give it a description. You can select the version that you're looking for. One of the standard things is tags that OCI uses. You can add any tags there that you have created or some of the standard ones that are in OCI. Next, we're going to hop down to the details of the database system. So if you want a test dev database system, you can select one node. You can go all the way up, as Dev mentioned, you can go up to 8 total nodes. So that's 1 primary and 7 replicas. And you can switch this around here. But we'll leave it at 1 for right now. Another thing you'll look at is the performance tier. So we do offer up to 750K IOPS. The way that you're able to unlock that is that you actually have to go down and select a larger shape because it's based on shapes. So if I were to go ahead and select a heavier system, more robust, let's just say we're looking for 32 CPU, 512 RAM, I unlock those extra layers of the performance tier. But we'll go back. We'll go to a smaller shape here. All right. So you select your IOPS and you can do a regional data placement or availability domain placement. So since it's a single node, I'll go ahead and I want to place an 82 in Ashburn. Select your processor and we'll go ahead and reselect a smaller shape here. So once you have all that selected, you can go down to configuring extensions. So the way that we do this in OCI is you create these configuration lists. These configuration lists, they give you certain variables that are dynamic and some are static, where the user can change things, such as, the wall level or anything like that. So I'll give you an idea of what that looks like. So I can go in here and change this to logical if I need to, and then I can save these and add another variable and everything, as many as I need to change those variables. You might hear those heard of as parameters with other management and other vendors, but we're calling those variables here. You can also enable any extensions that we have available. Now we have a long list of extensions that we support, and we're adding more and more as we move forward. You can do things like PG vector, you can do PG stat statements. That's in here as a popular one, as well as things like Postgres foreign data wrappers. But then that's how you save that there. You can select a configuration list based on what you need. Next thing is the standard, setting up your network or making sure that your network's in place. You can select a subnet, and then you can do things like use network security groups and enable reader endpoints. Another thing you can do is you can either input a password or you can use OCI Vault. We give you the flexibility to do that there. So we'll do that. Now we'll go ahead and change this one here and this one here for my vault. So I can go ahead and select one. I can select the secret and I can select the version of that secret that I have available. One of the other things as part of setting up your DB system is backups. Backups are incredibly important. So you can go ahead and enable automatic backups. You can do a frequency of daily, weekly, monthly. You set your backup start time and your retention period. And as Dev mentioned, you can do it up to 35 days. And another thing is the backup copy. That's where you're doing it to a different region. And you can select whatever region you want to ship your backup copy to, and you can set a retention there. And then the last part is going to be your maintenance schedule. So we give you the ability to set your maintenance schedule, or we can do it for you. You can go ahead and schedule your own maintenance. You select the day of the week, and you select the time you want to start, usually during less traffic periods. So there's that. And that's how you create a database system. I'm not going to go ahead and create one for sake of time, but I am going to go ahead and switch over to the video demo. So with this video demo, we're going to walk through a couple things. So I'm going to go into the database details view. And once I'm in there, I'm going to go ahead and change the IOPS in the performance tier. So I can select that, click submit. And then It's as easy as a few clicks, and then the system updates. The next thing is adding a node. So if you want to go with more high availability, you could add a node right there on the fly. And you can see that it's creating, and then the node will come back up. And so you have your primary and 2 replicas. The next thing is going to be the backup policy. So changing your backup. So if I go in here and edit my management policy, I can choose the frequency. I'm going to leave it at daily, but I'm going to change the retention period to three days. Yeah. And then I'll enable backup copy where I can ship that copy over to another region. I'll select my compartment that I want it in. Let's go with Phoenix. And then I'll set this for, let's just say 5 days. And so when I go ahead and I change those, I can save those changes. And then the system is updating. And then I can see the work request, see that it was accepted there. And so that's how you adjust your backup policies. So as we mentioned earlier, we are going to talk a little bit about the hybrid search. This is where we show you an application demo of turning a Postgres database into a vector database using a combination of OCI AI services and other services like object storage to create a hybrid search application with our services. So the logical architecture, this is a simplified version of it, where you have all your files here that you use. You take those files and then we upload those to OCI object storage. So what happens from there is that we have a couple of different OCI AI services that are working to convert those to text. And when they convert those to these text to these vectors, they then store them in Postgres, which is going to be our vector store. And the user on the other end, they can query the application using OCI Gen AI services, and it retrieves those depending on whichever service is being used, AI service is being used. So this is a very simple version of how it is. We do have this lab, this workshop up and available to use, and it's super easy and simple to use, and it actually generates a hybrid search application, which I will show you now. So a couple of things with this. This is what it would look like whenever you create this hybrid search application. I'm going to go ahead and play this recorded demo for sake of time. So one of the first things I'm going to do is I'm going to take a look at I'm going to query the system. Where did jazz music begin? And I want to use generative AI to get a response from that. And as you can see, it's pretty quick, and it comes back and it tells me the origin of jazz music there. So that's using our Gen AI service with our vector store. Next thing is I'm going to check where did rock, or I'm going to check on rock music and use our retrieval augmented generation. So as you know, with RAG, it takes a look at several sources, and then it's going to go through and give you a response based off of those sources that are there. And so that's one of the key services that we use as well. It gives you a summary of that. But it's not just limited to things like this where you're asking questions about certain text documents and files that way. Let's take a look at something else with an image. So we have a map in here. It's going to be a map of South America. So I can go in here and I can query this image. What is the southernmost country in this image? Now, I'm not saying that it's a map or anything. I'm just asking the system. And it tells me the southernmost country in the image is Argentina, as you can see. So that's one of our OCI AI services that identifies that as well. And the next thing I'm going to do is, let's see if we can do a video. So let's find a video here. Okay, we have an Oracle Analytics video. Let me refresh this. Okay, so we have the video loaded up. I can ask the application to summarize the video, what's inside the video without even watching it. So it gives me a summary of what is inside the video. It's a Oracle Analytics explanation video. I can even go a little deeper. Are there any quotes in this video? And it does give me a quote that's out of the video. So this is our hybrid search application, and you can actually use that now and build a hybrid search application on OCI. Okay, I'll switch back over to our.
Hey, Mike, and actually one thing, we had a question from Venkat in the webinar chat. Do you have the console open? Are you able to demo the cross-region backup copy?
Yes. Let me go over here. So if I have an existing system here, I can go in and edit the management policy. And so this is the cross-region backup copy. So you can see in this system, I have it enabled already. I have my compartment. I have my secondary region picked, so I could do it that way. If you are in a system that doesn't have it enabled already, then whenever you go and edit your management policy, you can do it that way. So you can edit it here to enable it, or to edit the actual policy that you have in place for backup copy to a different region. Or when you go through the steps to create a DB system, then that's when you can enable it from the very beginning there.
Perfect. Thanks, Mike. Hope that answers your question. Good.
Okay, and I'll turn it back over to you, Deb.
Great. Awesome. So we're about towards getting to the end here. So things to remember. I'd like you to walk away with Postgres. It's a powerful open source relational database system. It's reliable, it's robust, and it has advanced features. So it's a really great solution for enterprise scale for just getting started, really across the board, and it continues to gain popularity. At OCI specifically, we take Postgres and we offer a managed Postgres service whereby we automate the boring, if you will, but not necessarily boring, but operational tasks around high availability, patching, upgrades, backups, scaling, and compliance. And then Postgres, as well as our Postgres managed service, supports SQL standards, allows custom functions, data types, and extensions. Several resources for you here to take advantage of. One is the Live Lab. So if you want to go ahead and build what Mike demoed around the hybrid search with retrieval augmented generation functionality and kind of using that PG vector with Postgres to build an AI-enabled workload, we have a Live Lab for that. So you can definitely jump in and get your hands into that as well. We have a lot of links around our product page, documentation, extensions, and other tutorials that you can peruse to just get more knowledge and more comfortable with Postgres. So we want to get started with Postgres. Again, it's fully managed. We reduce your operational expense. It's faster. We back it up with availability SLA, and apples to apples, we cost less. So that's our service. And with that, I will go ahead and hand it back over to Borna. Thank you so much, everyone. Really grateful to have had you here and gotten the opportunity to present to you. Appreciate it. Thank you.
Awesome session. Thank you, Devin, Mike. I really appreciate your time and help with the session, and I hope it was a good learning experience for everyone. Also on our screen, we have, if you'd like to learn more, we have an overview of our program, as well as other offerings we have, from personal training to quick shot live labs. Today was a Day and Beyond session. There's a Code Innovate program as well. And if you're interested in our Day One Beyond series, we have additional learnings as well from our core series, Analytics Cloud series, as well as our hands-on series, Cloud Native Launchpad, Cloud Security series, as well as our Did You Know series. That being said, thank you again for your time today, and we'll see you all next time. Thank you and have a great day, everyone.